Let's look at what hexadecimal numbers are. As I already mentioned, everything is all about base and place. For hexadecimal number, we know that base is going to be 16. This is how a hexadecimal number looks like. You see this 0x, this tells the system that the number is going to be a hexadecimal number. This 7FA2 is a hexadecimal number represented by this 0x. Now we are talking about number, right? So what these letters are doing inside number? For that you need to understand and recall what base is. Base for hexadecimal number is going to be 16. That means at every single location you can have 0 to 9. But what about 10? We are talking about hexadecimal number system. So there can be 16 different possible combination at every single location, right? So 10 we are going to represent it by using A. 11 we are going to represent it by using B, something like that. So at every single location in hexadecimal number system, you can have 0 to 9 and A to F, while A is 10 and F is 15. Once you understand that, it is very easy for you to understand the hexadecimal number system as well. This 7FA2 is nothing but 7 into 16 to the power 3 plus F is 15. 15 into 10 to the power 2, 16 to the power 2 plus A is 10. So 10 into 10 to 16 to the power 1 plus 2 is 2. So 2 into 16 to the power 0. So this is the number that is represented like this in hexadecimal number system. So we know binary number system, we know decimal number system, we know hexadecimal number system, and we have the mechanism to convert binary number system back to decimal number system. We have the mechanism to convert hexadecimal number back to decimal number system. So no matter what number system you use, I will be able to convert that number into decimal number system. I hope that is clear. Everything is all about base and place when it comes to the number systems. But why do we need this hexadecimal number system? See, we understand why do we need binary. Binary is required because computers understand 0 and 1, on and off state. That's why we need binary number system. Decimal is for our understanding because it is very easier for us. But why do we need hexadecimal? Well, hexadecimal is for the people who are working with the computers. Why? Conversion from binary to decimal is very difficult. Right? You have to write that 1 into 2 to the power something plus 1 into 2 to the power again something. It's very difficult to convert. But converting binary to hexadecimal, it's easy. You take the group of 4 like this. This group of 4 is here and this group of 4 is here. Now you convert these values to decimal numbers. This is actually 11 and this is 13. For 11, we have B. For 13, we have D. That's why the hexadecimal for this particular number is going to DB. Very easy to understand, right? Very easy to convert as well. That's why binary to hexadecimal is preferred. Your eyes will be much more ready to convert it very easily once you have the practice. So, we use hexadecimal numbers for the memory address, embedded systems and networking. So decimal is understandable by humans, binary is for computers, hexadecimal is for the humans who build and work with the computers. As I have already mentioned, it's very easy to convert binary into hexadecimal. We just saw the example, right? And we use these hexadecimal numbers for the memory addresses because memory is like in TBs, right? In GBs or TBs. So lot of bits are going to be there. So every single memory has an address attached to it. If I want to represent that address into a binary, that number is going to be very huge. But in hexadecimal, it's very easy to represent. That's why we need hexadecimal. Now in competitive programming, we are not going to use hexadecimal system, but understanding of it is still good. So what we have covered till now is that you provide me any number system, I can convert that number back to decimal number system. Now we have understood that, right? We can convert hex to decimal. We can convert binary into a decimal number system. So you provide any type of number system. You give me the base, I can convert that to a decimal number system.